In this video, we'll be looking at tree diagrams and how they can be used to solve probability questions. A tree diagram is a way to show the outcomes of combined events. If you look at the tree diagram drawn below, we have two events or two experiments that have happened. In the first experiment, the two things that could happen are A or not A. And in the second experiment, the two things that could happen are B or not B. If you go along here, the probability of A is on the first branch. Along here is the probability of B happening given that A has already happened. At the end, you get the probability of A and B. If you go along this branch, you get the probability of A. Along this branch, you get the probability of not B given A, and that gives you the final combination of the probability of A and not B. If you go along this branch, you get the probability of not A. Along this branch, you get the probability of B given that not A has happened. That gives you a final outcome of the probability of not A and B. And finally, if you go along this combination of branches, you get the probability of not A, the probability of not B given that not A has happened. That gives you the probability of not A and not B. Question 1. A bag contains 13 yellow and 7 green tokens. 2 tokens are drawn from the bag without replacement. Draw a tree diagram to represent this information, then calculate the probability he chooses A yellow then green token, B, 2 tokens of the same colour, C, not 2 green tokens, D, green on his second turn, given he chooses yellow first, and E, yellow on his first turn, given he chooses 2 different colours. The first thing we need to do is draw our tree diagram. Here's our tree diagram drawn for 2 events. Now let's fill in the relevant information. Right, we could pick in the first choice a yellow or a green token. If we pick yellow on the second choice, we could still pick green, yellow or green. If we pick green on our first choice, we could still pick yellow or green for our second choice. Now let's fill in the probabilities. So if on our first choices, there are 13 yellows out of 20, so the probability is 13 out of 20. If we pick green, there are 7 green out of 20. Now let's fill in the second choices. If we've already picked a yellow, on the second choice there are only 12 yellows out of 19 balls, because one has been removed. If we pick green second time, there are still 7 in the bag out of the 19. If we've picked green first, there are still 13 out of 19 in the bag. And if we've picked green, there are only 6 green left out of the 19. Just one other thing I need to point out. When you are dealing with tree diagrams, when you cross from branch to branch, you multiply the probabilities together. Now let's answer the questions. So A, we want the probability of a yellow then a green token. Well, that is 13 out of 20 times 7 out of 19, which is equal to 91 out of 380. Part B, 2 tokens of the same colour. That means I could have yellow and yellow, which is 13 out of 20 times 12 out of 19, plus 2 red, which is 7 out of 20 times 6 out of 19. When you multiply those and add them together, you get 99 out of 190. Part C, we want not 2 green tokens. That means we want anything but 2 green tokens. So we want 1 minus the probability of 2 green, which is 7 out of 20 times 6 out of 19, which when you work it out comes to 169 over 190.
D. Green on his second term, given he chooses yellow first. This sounds difficult, but it's actually easier than you think. Yellow first has already happened, so we're already here. So that has already happened. We don't have to take that into account at all. So we want green. So the probability, green on his second term, given he chooses yellow first, is quite simple. It is just 7 out of 19. Part E. Yellow on his first turn, given he chooses 2 different colours. This is actually the hardest of the lot, and because it has given in the question, I know it is conditional probability, and I have a formula for conditional probability, which is in your formula booklet, and it states that the probability of A given B is equal to the probability of A and B over the probability of B. So the probability of them both happening over the probability of the second. So I want the probability of yellow first, given I have 2 different colours, is equal to the probability of yellow first and 2 different divided by the probability of 2 different. Well, the only way I can get yellow first and have 2 different is if I picked green second. So that is equal to 13 out of 20 times 7 out of 19 on the top. And that is divided by 2 different, which could be yellow and red, which is 13 over 20 times 7 over 19, or green and yellow, which is equal to 7 over 20 times 13 over 19, which is equal to 91 over 380 divided by 91 over 190, which equals 1/2. Question 2. 20% of people in a company wear glasses. 40% of people in the company who wear glasses are right-handed. 50% of people in the company who don't wear glasses are right-handed. A. Draw a tree diagram to represent the information. B. One of the people in the company are randomly selected. Find the probability that they are right-handed. C. Given that a person who is right-handed is selected at random, find the probability that they wear glasses. The first thing we've got to do is draw our tree diagram. So here's our tree diagram with two events. So let's fill in the relevant information. The first piece of information is that they either wear glasses or don't wear glasses. And the probability that they wear glasses is 0.2 or 20%. So not wear glasses is 0.8. And the second thing is either they are right-handed or not right-handed. Right-handed or not right-handed. So, if they wear glasses, the probability that they are right-handed is 0.4. The probability that they are not right-handed is 0.6. If they don't wear glasses, the probability that they are right-handed is 0.5. So the probability that they are not right-handed is also 0.5. Part B. One of the people in the company are randomly selected. Find the probability that they are right-handed. Well, for B, we could have the probability that they wear glasses and are right-handed, or we could have the probability that they don't wear glasses and are right-handed. Well, that is equal to 0.2 times 0.4, or means and add 0.8 times 0.5, which is equal to 0.08 plus 0.4. So the probability right-handed is equal to 0.48. Part C. Given that a person who is right-handed is selected at random, find the probability that they wear glasses. So we are wanting to find the probability that they wear glasses given they are right-handed. Well, this is conditional probability, so we want the probability of both happening, so glasses and right-handed, divided by the condition, which is the probability of right-handed. Well, that is equal to 0.08 divided by 0.48, which is equal to 1/6.